At this time, we move on to our second presentation. The title of our second presentation is Playing the Long Game, Voice Computing to Support Education. It's an interesting title. I look forward to the contents of the presentation, and the presenters are right here. We have Dr. Laurette Marais, who is a senior engineer at the CSIR. We also have Ilana Wilken, who is a senior knowledge applicator at the CSIR. And I will hand over and leave you in their capable hands.
Thanks, Lama. And good afternoon, everyone. So today I would like to talk a bit, well, Ilana and I actually would like to talk a bit about the voice computing group's thinking behind a recent shift to focus on applying our resources, research and technology to education. So especially at the CSIR, when we talk strategically about building pipeline, it's often at the postgraduate level, postdoc, maybe at the undergraduate level. But it isn't often that we think about how we can pull the conversation towards high school learners or even primary school learners. And of course, education is the whole spectrum. And in South Africa, we don't have a human resource scarcity, of course, but we do have a skilled human resource scarcity. And what we have realized at voice computing is that we have the technology, the opportunity to perhaps try and address this problem almost at the moment where it starts to develop. So obviously, although early childhood education, early childhood development is crucial, our focus at the moment is on the foundation phase because there the focus really is on literacy. And so literacy is strategic because that is kind of the key to a life. So the UNESCO definition of literacy is the ability to identify, understand, interpret, create, communicate, compute using printed and written materials associated with varying contexts. It involves a continuum of learning and enabling individuals to achieve their goals, to develop knowledge, their potential, and to participate fully in their community and society. And so it's clear from this definition that a child that is left behind at this point in their education is missing out on being part of society at large in our modern world. So the long game is really starting where the problem starts as early as we possibly can. And so the context in South Africa has a few unique aspects to it, of course. So we are a proudly multilingual society, and we offer home language education at the foundation phase. And this is crucial. Again, from the UNESCO article on mother tongue education, research shows that it is a key factor for inclusion and quality of learning. Also improving learning outcomes, academic performance. It's crucial, especially in primary school, to avoid knowledge gaps and increase the speed of learning and comprehension. But as you may know, South Africa is not faring very well in making this happen. So 78% of our grade 4 learners cannot reach the lowest benchmark for literacy, as tested by the PEARLS. It's an international benchmark test. The most recent one, the most recently reported on one was conducted in 2016, reported on in 2017 and later. And this is a shocking statistic. In fact, and it's part of the conversation about this is a concept note by a number of professors from various universities in South Africa. And what they say is that the fact that most children do not learn to read fluently and with comprehension by the end of grade 3 in any language, so mother tongue, English, as it may be, is arguably the binding constraint to improve educational outcomes for the poor. A major contributing factor that I don't think has necessarily received enough attention is the fact that there is not enough research done on teaching reading of the African languages, because they are structurally different from languages like English, in which a lot of the research in the world is conducted. And so we have this bilingual education system. Typically, a child who maybe speak isiZulu at home or so on will start their education in their mother tongue, and then from grade 4 onwards typically move to English as the language of learning and teaching. And so this means that because of this, our children, the majority of children in South Africa, need to not only become fully bilingual, but biliterate by the time they end grade 3. This is a massive challenge. So let me quickly give some definitions of language as this problem or this context. The experts in this context talk about it. So home language, obviously the language spoken at home. First additional language, we all know what that means, and in a lot of cases it's English. And then the language of learning and teaching is the language that is mother tongue in the first 3 years and then typically moves to English, although it could be Afrikaans, from grade 4 onwards. And so very often what happens is the home language and the first additional language are taught in foundation phase, and then the first additional language becomes the language of learning and teaching from grade 4. Right, so we are at voice computing. How might the right technology help this situation? So the first thing to think about is what kind of requirements this technology would have. The first is, of course, reliability. The technology itself, I don't know if you've used Google Translate, it's very funny when you type in things, but it's not reliable. And if we do not have reliable technology, then we are not respecting the learners and the learning process. So the technology must be reliable. And in the same breath, it has to be developed with a focus on the African languages. The languages themselves must be respected in this way. So that's why reliability is important. It needs to be scalable. So more than 1 million grade 1s start every year. We have a lot of kids to reach in this country. And not only is it the sheer number of children, but we also have 11 official written languages in this country. So it needs to scale in that dimension as well, whatever it is that we develop. How is voice computing, language and voice computing, the right solution, or a part of the right solution? Of course, learning to read means going from ability in the oral modality in a language to the written modality. And this maps relatively neatly to the idea of speech processing and text processing. And so in our group, we combine that. And so we think we can make a difference in this way. Of course, we are only complementing traditional ways of teaching. Technology is not a replacement in all ways, but there are some aspects of this that could be automated, and we need to think about what that is. Of course, when you put a tablet in a child's hands and they can learn something from it, there's some empowering that come from being in the driving seat as such. So we think that technology can also empower and enable learners to take things into their own hands, in a sense, with the help of the teacher. So we want to empower children. And of course, scalability with technology is almost baked in, right? If you develop the right kind of application, in principle, it can be run on millions of devices. So, I want to give a bit of a quick overview of what has been done, what is currently being done, and what we intend to do in the future. So in the past, the most voice computing-like solutions have also always used kind of this phrase book approach with canned content. So the content is canned, it's developed with lots of care upfront, but it's canned, it's very fixed. So whether that is text that has been canned and voice recording. So you put someone in a studio and make them record a bunch of things, and that's the content that this digital application can deal with. And that has worked so far, but it's not very scalable. At present, we have started to try and apply our technologies in some ways to the education space. And so what Isinkwe does is it empowers eyes and ears. It's basically an application that can consume ebooks in different formats and produces audiobooks of the same. And so this technology is it can be used to enhance the learning process, especially of children that may be sight disabled or in some other way have learning difficulties. But we want to move that forward. Oh, I should mention also that it uses one of our other products, Qfluency, which is our suite of text voices in all the South African languages, male and female. In the future, which is kind of now, we want to change our focus or enhance our focus a bit towards high accuracy, natural language processing so that we can get some scalability. We want customized and expressive synthetic voices. So we have good synthetic voices, and I would say they are the state of the art. In some cases, the only art available for our languages, but we want to customize them and make them very expressive for the right context. And then we want to use automatic speech scoring to enhance the learning process. So let's look at an example, Ngiyakonda. This is a project funded by the Department of Sport, Arts and Culture that we're very excited about. It basically takes all of our technologies and presents it in a mobile application. We're using computational grammars, text-to-speech, so that's where you get in text and you synthesize it using a synthetic voice, and automatic speech recognition. And the idea is to improve the learning ability of grade 3s, not only in their home language, but also in the language of learning and teaching for grade 4 and beyond. So essentially what the application does is it creates a speech-enabled digital learning environment that essentially allows children to practice constructing sentences that are correct in their mother tongue and first, and then in the language of learning and teaching. And we use voice computing to make this a reliable environment within which to learn. I want to quickly touch on a few of the technical aspects of how we do this. So we use computational grammars to do our language modeling. This is in contrast to something like Google that uses a data-driven model. So a computational grammar is essentially a model of the language where the rules are explicit and it's software. The model is a piece of software. So any mistake in the model is essentially a bug that can be fixed instead of a model that has to be retrained with different data. The scalability is in the fact that you have a piece of software where a sentence essentially becomes a composition of a number of different functions. And so if sentences are composed of a number of functions, then you can automatically generate thousands of examples that are correct. And you can manipulate them. They are computational artifacts that you can change in predictable ways. And also an important part of this, especially in our context, is if you have an explicit model that tells you how the language works, then you can rely on the linguistic similarity of the other African languages. You can bootstrap. So you start with a model of isiZulu, and you can get an isiNdebele model, very simply because there are systematic differences in the languages that are known, and linguists know about them, and we can use that. So that little picture gives you an idea of what the model can do. It knows what words can follow legally in the language. So uvusi, you choose the first word, it's uvusi. Then the model knows that you can say uyahamba or ufuna, but you cannot say ngibona. I see, because vusi is not me, so you can't say ngibona. If you say uyahamba, your sentence may be finished. If you say ufuna, then the model expects you to say something more about this because you haven't finished the sentence yet. And so that's how we allow learners to construct correct sentences. We need reliable text-to-speech. So we have our commercial product available, but and it's inherently scalable, right? You can give any sentence to it. If you've generated thousands of examples, instead of having someone sit in a studio and record thousands of examples, you can give it to the synthesized voice. And if it's a reliable voice, you have scalability. So I'll get to that. But in order for that to work, it has to be natural. It has to be expressive. So we're working on the expressiveness, the tone, especially you would know that tone is important in these languages. And to capture emotion, because if you're teaching children, you're typically using stories, and the emotion has to be right. And then, of course, you want to adapt our voices. So to get a child voice, you need many hours of child data, and I don't know if anyone has sat in a studio recording with a child, but that's quite difficult. So we use voice adaptation techniques to take a small amount of data and use a baseline model and then adapt the model. So you start with a kind of an adult voice model, use a little bit of data, adapt it, and then you have a child voice. And so that's how we get some scalability so that we have different voices suited to different use cases. In the automatic speech scoring, what we do is we use automatic speech recognition techniques. So automatic speech recognition is where you take in audio and it tells you what the words were that were said. So you go from audio to text. And we use those techniques to do scoring of fluency as well as pronunciation. And in order to get this to be reliable, we have to adapt our models to child speech. And not just child speech, but fluency for that specific age. So we have to have models that model that accurately. And of course, the scalability comes in again with the language similarity. So a model for one language, the acoustic characteristics of a model for one language, one African language, would be very similar to a different African language. And so we get scalability by leveraging off of the systematic similarities between our languages. And so all these technologies together create a digital environment that my colleague Ilana will now talk about a reliable and scalable learning environment.
Thank you, Laurette. Good afternoon, everybody. So each technology that Laurette mentioned plays an important role in creating a reliable and learning environment. We also use human-computer interaction principles to ensure user needs are taken into consideration when we are doing the designs. Two main processes that ensure we do this is developing wireframes and writing user stories. They form the core of the application, of any application that we develop, and it ensures that we put the user first. User stories are informal, general expressions of software features that are written from the point of view of the end user. We use user stories to articulate how a software feature will provide value to the end user through the product. Here are 3 user stories from our application. Each user story is linked to a functional requirement that has a unique number and a title. A user story is short and concise, and it addresses only one feature at a time. As an example, for the functional requirement to construct a sentence, the user story reads, "As a learner, I want to listen to a sentence in my home language and rewrite it by dragging words from a list of correct words to an available space and clicking a button to add it to my story." This is an example of a wireframe. A wireframe is a blueprint that is useful for helping designers and developers to communicate and think about the structure of an application before it is being built. A wireframe is also known as a mock-up, and they are quite useful to show to clients or to end users as a way of confirming requirements before any development takes place. Here is one of the screens that we have designed, and it shows the functional requirements I showed in the previous slide and how they have been designed graphically. The user story I read out is addressed by first clicking on the button with the ear icon, which then plays the sentence in the learner's home language by means of TTS, or text-to-speech. The learner then drags the correct word or the word that they have chosen from the blue block to the green block. And once they are done with their sentence, they can click on, or the sentence is then moved over to the Your Sentences section. Comments have also been made in the yellow post-it notes on the right-hand side, and these comments are for the developers to ensure that they know what exactly it is that the design wants of them and how it links up with the functional requirements. When used in conjunction, user stories and wireframes can ensure that a product is developed that meets the end user's needs before any code is written. So you save space, save time and money in the end. When combining all the technologies and the human-computer interaction principles, they provide a wholesome and reliable learning experience. Our technologies are only worth developing when they can be placed in human hands. It does not benefit anyone if we design all these technologies and we aim to make a difference if we cannot place it with real people, and we only end up stay in our ivory towers and never really go out and test it with real world people. We are thus planning on conducting a pilot study to establish if this application will improve reading and writing skills of learners in the foundation phase. The pilot study will be planned and conducted under the guidance of an isiZulu's expert and an expert in foundation phase development, and it will involve an intervention and control group at a school in Gauteng for grade 3 learners. The intervention will run over the course of a year, and it will allow the participants to use the application once a week during their reading lesson. And we see the intervention thus as supplementary to their everyday learning methods. Once we know if the application has had an impact on how learners read and write, we can introduce it to more schools and more learners so that they too can benefit from voice computing applications. By applying voice computing technologies in real-world environments, we can make a real difference in the lives of ordinary South Africans. Thank you.